The Internet, an invention that changed everything. It all began in 1969 as part of a research project, and by the 90s, it became a global sensation. Now, here you are, watching this video thanks to that very invention. But have you ever stopped to think about how it actually works? The video you're seeing right now traveled thousands of miles through data centers, cables, and servers to reach your screen. Join us as we dive into the remarkable journey of data across the web. It's more incredible than you might think. The video you're watching right now, stored in a data center thousands of miles away, traveled an astonishing path to reach your device. While satellites might seem like an obvious way to transmit data, they're not the most efficient. You see, satellites orbit about 22,000 miles above the Earth's equator. To transmit a signal from a data center to your phone via satellite, the data would have to travel a whopping 44,000 miles. That's a huge journey, causing major latency. For most internet applications, that delay just wouldn't cut it. So how does the video get to you? The answer lies in a complex web of optical fiber cables stretching across the planet. These cables are the backbone of the internet, transmitting data at lightning-fast speeds. Whether you're connected via cellular data or Wi-Fi, at some point, your device is tapping into this global network of fiber optics. Let's zoom in on the data center for a second. That video you're watching isn't just floating in the air. It's stored in a solid-state drive, SSD, within a server, a powerful computer specifically designed to deliver content when requested. When you hit play, the server jumps into action, sending your video on a remarkable journey through the web of cables, routers, and switches until it arrives on your screen, all in the blink of an eye. This intricate process is happening every time you stream, download, or browse, seamlessly connecting you to the vast world of information stored across the globe. So, how does the data stored in a faraway data center make its way to your device through the intricate web of optical fiber cables? It all starts with something called an IP address. Every device connected to the internet, whether it's a server, a computer, or your phone, has its own unique IP address. Think of it like your home address. Just like how mail gets to your house thanks to your home address, data finds its way to your device using your IP address. Your Internet Service Provider, ISP, assigns an IP address to your device. Likewise, the server in the data center that holds the website or video you want to access also has an IP address. Technically, if you know a server's IP address, you can directly access the website it's storing. But remembering strings of numbers for every website isn't practical, right? That's where domain names like youtube.com or microsoft.com come in handy. They act like nicknames for these hard-to-remember IP addresses, making the internet more user-friendly. Here's where things get more interesting. A single server in a data center can host multiple websites, and each of these sites can't be accessed just by knowing the server's IP address. In cases like this, something called host headers are used to ensure that when you enter a domain name, the right website pops up from that server. But for massive websites like YouTube, they've got entire data centers dedicated solely to storing and managing their content, so things are a bit more streamlined. When you enter a domain name like youtube.com, your browser doesn't immediately know the IP address behind it. That's where the DNS, Domain Name System, steps in. Think of DNS as the internet's giant phone book. Just like you'd look up a person's phone number by their name, DNS matches domain names with their corresponding IP addresses. Your internet service provider or other organizations manage these DNS servers, ensuring that when you type in a website, it's connected to the right IP address. So, let's recap this whole operation. When you enter a domain name in your browser, it sends a request to the DNS server to fetch the matching IP address. Once it gets that IP address, your browser forwards the request to the data center that holds the website. The server inside that data center then sends the website's data through the optical fiber cables until it lands on your screen. When a server receives a request for a website, the flow of data begins. This data is transferred in digital form through optical fiber cables, specifically as light pulses. These light pulses often have to travel thousands of miles through rugged terrain, across mountains, and even beneath the ocean. Global companies lay and maintain these vast networks of cables, which act as the backbone of the internet. Take a look at how it's done. Ships drop a massive plow deep into the ocean, digging a trench on the seabed where the optical fiber cable is placed. These cables, stretched across the sea floor, carry data all the way to your doorstep. Once they reach you, they're connected to a router. The router's job is to convert these light signals into electrical ones. From there, an Ethernet cable transmits the electrical signals to your laptop or device. But what if you're using cellular data? In that case, the signal moves from the optical cable to a cell tower, and from the cell tower to your phone as electromagnetic waves. Whether through fiber optics or cell towers, this intricate network keeps the internet flowing seamlessly. Given that the internet is a global network, there has to be some organization to keep things running smoothly. That's where ICANN comes in. Located in the USA, ICANN oversees crucial tasks like IP address assignment and domain name registration, ensuring the internet functions the way we've come to rely on it. All this happens in milliseconds, bringing the world to your fingertips with every click. One of the most incredible things about the internet is just how efficient it is at transmitting data, far outpacing older communication technologies like landlines and cellular networks. Take the video you're watching right now. It's sent from the data center to you as a massive collection of zeros and ones. But instead of sending it all in one go, these bits of data are chopped into smaller chunks called packets, which is what makes the internet so fast. Here's how it works. The server divides the video into packets, each containing 6 bits of data, along with important info like the sequence number and the IP addresses of both the server and your phone. These packets are then routed toward your device, but they don't necessarily follow the same path. Each one takes the best available route at that moment. Once all the packets reach your phone, they're reassembled in the correct order using the sequence numbers. If any packets get lost along the way, your phone automatically sends a request to have them resent, ensuring the video plays without a hitch. It's like a well-organized postal system, but imagine if the senders didn't follow the rules. Letters wouldn't reach their destination. Thanks to the structure and efficiency of the internet, though, those tiny packets of data make their journey seamlessly, bringing you this content in real time. Now, in the world of the internet, protocols are what keep the flow of data packets organized and efficient. These protocols are like rulebooks that manage everything, from converting data packets to attaching the source and destination addresses, and even setting the guidelines for routers. Depending on the application, different protocols come into play, making sure everything works smoothly. Protocols dictate how technology operates, defining the ways data is shared and the amount of data that can be transferred. Both the sender and receiver must follow these rules to communicate effectively. Protocols fall into three major categories: TCP, IP, FTP, and HTTP. The foundation of the Internet is HTTP, Hypertext Transfer Protocol, which is what allows us to communicate across the World Wide Web. HTTP governs the transmission of data, like images, videos, and text across the Internet. Each time a user opens a web browser, they're automatically establishing an HTTP connection, allowing them to access all sorts of content. We hope this video has helped you understand how the Internet works. If you enjoyed learning about this process, please consider subscribing to our channel and liking this video. Your support means the world to us. Thank you.